I'm Eve Torrence, and I'd like to take you on a quick tour of the fascinating world of modern mathematical art. M.C. Escher made this wonderful woodblock print based on hyperbolic space over 60 years ago, and his work has inspired generations of artists. But as an example of how far mathematical art has come, here is a mathematical distortion of Escher's print by Vladimir Bulatov. It has been mapped into 3 dimensions, distorted in hyperbolic 3 space, and projected back into 2 dimensions. I think this work would have delighted Escher. This tour will show work by just a few of the many mathematical artists working in this growing field. At the end, I will show you how you can explore more mathematical artwork. One of the things I love about mathematical art is the way it shows the creativity and diversity of modern mathematics in media that can be enjoyed by everyone. This image of the Mona Lisa by Bob Bosch is made from exactly 12 complete sets of dominoes. They've not been cut into squares to create the image. Instead, Bosch has kept the dominoes as rectangles and used optimization to create this portrait under that constraint. This image by Roger Antonsen is a visualization of 8 different ways to perform perfect card shuffles. Tracing the position of each card creates these beautiful sinuous patterns. This work by Eve Torrence shows the complex patterns formed when a pile of sand spreads as grains are added and toppled according to simple rules. And this very effective yet simple composition by Mark and Marion Chamberlain portrays the numbers 0 through 63 in binary using color and shape. This quilt-like print by Margaret Kepner is based on the magic square. The numbers are depicted visually using 2 number systems, one in color and the other in black and white. Frank Farris has developed a complete system of mathematics for creating images such as this using transformations of photographs in hyperbolic space. And this is a delightful portrayal of Triacontahedral tiles by Carrie Mitchell. Triacontahedral tiles are a simple system of tiles that can form a wealth of patterns. This painting by Gwen shows how a simple set of rules, called cellular automaton, can form complex and surprising patterns. A set of rules and a coloring of the top row of squares is chosen. The rest of the painting is then predetermined and developed in a very systematic way, yet forms surprisingly complex patterns. This origami work by Gwen is folded from a single sheet of paper. It depicts a tiling by triangles, squares, hexagons, and dodecagons. And this piece by Alessandro Beber is also folded from one piece of paper, and it achieves a remarkably 3-dimensional looking image of a mathematical object called the Menger sponge. Mathematical artists work in many different mediums. This beadwork by Susan Goldstine is a demonstration of a theorem that says it's possible to create a set of regions on a 2-hole torus where every region touches every other region. And here's some beautiful beadwork by Gwen based on a variety of 3-dimensional shapes called polyhedra. Polyhedra are the 3-dimensional version of the 2-dimensional polygons. Many mathematical sculptors create sculpture based on polyhedra. Here's some more examples. This ceramic sculpture by Robert Fathour is based on a Goldberg polyhedron with 60 hexagonal faces and 12 pentagonal faces. Christina Bursick created this sculpture using the tension of curled paper without any adhesives. This is my work. It's based on the polyhedron called the Rhombic Triacontahedron, which is made from 60 rhombi. It is meant to portray the type of lava that forms a ropey surface when it cools. These are gorgeous examples of the traditional art of Temari by Kiyoko Urata. Temari balls are created using a framework based on the symmetry of regular polyhedra. The artist creates a grid based on a polyhedron and then sews the pattern using embroidery thread. There are many ways to use fiber arts to express mathematical ideas. This quilted sphere by Corinna Beuermann-Kulp shows an adorable tessellation of a sphere by 24 identical kangaroos. Crochet has become a popular way to create models of hyperbolic space. Gabriela Meyer creates monumental sculptures using yarn and light. These paper sculptures by Ulrich Miklovit show the 4 stellations of the dodecahedron. Stellations are formed by extending the faces of a polyhedron until they intersect to enclose space. Stellation is used by many mathematical sculptors to create interesting forms. These artists include Rinus Roelof, who creates paper sculptures using interlocking pieces and no adhesives. Rinus has created paper sculptures based on a great variety of polyhedra. George Hart is very well known for his sculptures based on a variety of geometric concepts. And 3D printing has opened up a world of possibilities for mathematical forms. This is a stellation-based sculpture by Vladimir Bulatov. It is 3D printed in bronze. This 3D print demonstrates a complex mathematical idea with a charming ball of monkeys. Finally, one of my favorite mathematical art surprises is these 3D printed objects by Hans Cooper and Walt van Balagogen. They create multiple images when light is shown through them in different directions. This one uses 3 directions to depict Gödel, Escher, and Bach. And this one is truly amazing in that it can create 4 images. The 4 images of the Beatles can all be seen at once by using mirrors. I hope I've piqued your interest in mathematical art. You can explore further by visiting the mathematical art galleries posted on the Bridges Organization website. The Bridges Organization hosts an annual international conference on mathematics and the arts, and art exhibitions are just part of the conference. All pieces from the many years of exhibits can be found online at this website. Just click on the thumbnail image for a piece to see the full image and read the artist's statement and descriptions of the artwork. Here is a piece by Brianna Butler from a recent exhibit. It's a model in stained glass that depicts the result of very recent research about polyhedra. I hope that you will enjoy exploring the beautiful, complex, charming, and accessible world of mathematical art, and that it will fuel your love of mathematics.